Let's see question number 39. An n-type of semiconductor is formed. Obviously, we have already seen the n-type semiconductor is formed due to the doping of pentavalent impurities. Okay, and p-type semiconductor will form due to the doping of trivalent impurities. So we here they have asked an n-type of semiconductor is formed. So option B is correct because when we add germanium crystal, when germanium crystal is doped with an impurities containing 5 valence electrons. Okay. Now question number 40, that is LED is a PN junction diode, which is obviously LED is when we connect LED in forward bias condition at the junction, holes and electrons uh, combines at the junction and it emits energy in the form of light. Okay, basically it is made of the made of the gallium arsenide. Okay, so option A is correct option for this. So let's see question number 41. Which one of the following statement is false? We have to find the false statement. Okay. A statement is pure Si doped with the trivalent impurity gives a p-type semiconductor. Obviously, it is true. Option B, majority carriers in n-type semiconductors is holes. No, it's wrong. For the n-type semiconductors, the majority carrier is electrons. Free electrons is the majority carrier, and the minority carrier is the hole. So I think option B would be the false option. False option. Rest minority carriers in p-type conductor are electrons. Is true. Last one, the resistance of intrinsic semiconductor decrease with the increase in temperature. This is also true. Okay, so B is the correct answer because this is the false. Okay, now let's see question number 42. Which one of the following statements is correct in case of the light emitting diodes? Okay, which one of the following statements is correct? We have to find the correct statement. So let's see. It is heavily doped PN junction. It emits light only when it forward bias. Obviously, uh, we know that the LED only emits light when it's forward bias because when we connect the LED diode PN junction diode in forward bias at the junction, it emits energy, okay, in form of the light. So option B is the correct option. So let's see question number 43. Avalanche background in a PN junction diode is due to obviously uh, when we when we connect the diode in reverse bias, it's when we connect the diode in reverse bias, it's suppose if you'll see the graph, when we connect this is the this is the mm, VI characteristics of the reverse bias of the diode. So this is I and this is V. At a valence breakdown, at this point, breakdown take place and current increase sharply. Okay, so the cumulative effect of conduction band electrons collision. Okay, so we can say option D is the correct option because at the junction, at the junction, there is at the junction there is the pair of electrons uh, get get liberated. Okay, it's liberated and collisions occurs. Okay, we can say that the electrons collision occurs and rapidly increase the avalanche condition. Okay, so this would be the option D would be the correct option for this. Let's let's see question number 44. A silicon specimen is made into a p-type semiconductor by doping on an average one indium atom per 5 into 10 to the power 7 silicon atoms. Okay, if the number density of the atom in the silicon specimen is 5 into 10 to the power 28 atom per centimeter. Okay. Then the number of acceptor atom of the silicon per cubic centimeter will be. Chलिए, let's see. So, mm, number density of the silicon is given. Number density of silicon is given, that is 5 into 10 to the power minus 28. 5 into 10 to the power minus, no, that is not minus, that is the 5 into 10 to the power 28. Okay. Atom per meter cube. Atom per meter cube. As you can see that the answers are given in centimeter cube. Okay. So per cubic centimeter, we have to calculate in per cubic centimeter. So we need to convert it in cubic centimeter. Okay, 5 into 10 to the power 28 divided by 100, or we can say that 10 square meter cube. So by solving this, we will get 5 into 10 to the power 3 to 5. 28 minus 5, it would be 22. That is the atom per centimeter cube. Now what we have to find? We have to find the number of acceptor atoms in silicon per cubic centimeter. So we can simply divide the number of atoms to this number density, divide the number density to the atom one doping, number density and doping of an average 1 ID. So just do this, 5 into 10 to the power 22 divided by 5 into 10 to the power 7. Okay, 5 into 10 to the power 7. Okay, by solving this, this 5 will get cancelled, this 5 will get cancelled, this will goes 10 to the power, result would be 10 to the power 15 atom per centimeter cube. Okay, so 10 to the power 15. D is the correct option for this. So let's see question number 15. This is the assertion reasoning. Assertion: the resistivity of a semiconductor increase with the temperature. No, 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 no. It will decrease. It will not increase. When we increase the temperature, obviously, the movement of electrons collision will increase, and uh, obviously resistivity will decrease. Conductivity will increase. More free electron will start moving. Uh, so assertion is false. Now, reason, let's see the reason. The atom of a semiconductor vibrate with larger amplitude of higher temperature, thereby increasing its resistivity. Obviously. Okay. So I think option D is the correct option. Okay. Let's see question number 46. The detecting intensity of light we use. Obviously, for the intensity of light, Light intensity, we use the photodiode. Okay, photodiode just collect the light at the junction. Okay, and when we connect photodiode normally connected in reverse bias for the conduction. So I think option number B is the correct option. So B is the correct option. Photodiode in reverse bias. Okay. Now, what control the conduction of PN junction? Obviously, PN junction conduct due to the majority charge carrier, and that is the holes. Holes basically controls the conduction of the PN junction diode. Okay. The typical ionization energy of the donor in silicon, it's around, it is 0.1 electron volt. Okay. In case of 49, question of 49, the value of DC voltage in half rectified in converting AC voltage V is equal to 100 GM 312 omega T. Okay, then DC. So what we have to, let's see, question number 49. So the formula for this is V, we have to find the VDC, no? VDC is equal to V naught by pi. So this is the AC current and this is the value of 100 is the value of V naught. Okay, this is the V naught. So put the value of 100 instead of V naught, and pi, obviously pi is 3.14. Now just divide and calculate it. This you will get the almost 30.33 volt. Okay, so C may be the correct option. Now see question number 50. If parameter alpha is 0.9, the value of the parameter beta is, so uh, see question number 50. We are having the relation between alpha and beta. Okay, that is, if you will remember, beta is the current gain of the common emitter amplifier and alpha is the current gain of common base amplifier, and we are having the relation between them. Beta is equal to alpha divided by 1 minus alpha. Now we can put the value of alpha. Alpha is given 0.9 divided by 1 minus 0.9. When we are going to solve 0.9 divided by 0.1. If we will solve it, we will get the answer. The value of beta is 9. Okay. So option D is the correct option for this. A simple relation formula based problem. We are just putting the formula value in the formula and we can get the result. Okay, this is the relation. Beta is equal to alpha divided by 1 minus alpha. Okay, this is the